going to solve today, that is message route. CSES network has n computers and n connections. Your task is to find out if we can send a message to May, and if it's possible, what is the minimum number of computers on such a route. Okay, so you have given n computers and m connections. These are the connections. That is, there is a connection between 1 and 3, between 1 and 2, between 1 and 4, 2 and 3, and 4 and 5, right? So these are the connections between the computers. And I made a corresponding adjacency list to this undirected graph, right? And what we have to tell, there is a root there is a root between 1 and 5, that is between 1 and n. So you can see that there is a root that is 1, 4, and 5, and this is the root which has minimum number of computers, right? And right, we have to print it 1, 4, 5, right? The similar problem we had done, which is labeling, right? In which we print path description using parent array, right? And we uh, we also found that there is a path between A and B, right? By using BFS, right? We did BFS traversal, and if there is a path, then if the B if the B position visited, then there is a path, and otherwise, no, right? So this is a similar problem. Now let's see how we can solve it by using TFS. Right? The idea would be similar, and if you are follow the series from the very first video, uh, you can do it by yourself. Let's see it. So we start with the DFS, right? Right. One is not visited. Initially, these all are not visited, right? And we start with the DFS one, and we mark it as visited, and DFS of one, right? So first call goes on DFS of two, mark it as visited, and who is the parent of wait, first who is the parent of one? The one itself, and who is the parent of two? It is one, and then the call goes on DFS of one, which is already visited, right? And the call goes on DFS of three, right? So DFS of three, and who is the parent of two? Three, that is two itself, right? Then the call goes on DFS of four, right? Mark it as visited, and who is the parent of four? That is one, and then the call goes on DFS on five, and who is the parent of five? Which is four, right? So this is how you can, by using GFS, you can make a parent array, and by using this array, we can print the root. Now, cur equals to n minus 1, which is equals to 5, or we can say cur equals to n, which is equals to 5. So while cur not equal to 1, we store our dot add answer dot add cur, and we make a cur equals to parent of cur. Right. So in answer, what we have, so first 5, and parent of 4 is 1, and parent first we have 5, and parent of 5 is 4, and parent of 4 is 1. So 1, 4, 5, reverse it, and this is our answer. Right? Perfect. So now let's see how we can, now let's see the, so we just copy the previous code, right? Perfect. And we make a parent array, parent int int parent, right? Of size n. Then we pass the parent array also, parent parent of adjacent node is equals to node. Right? Perfect. Now we have to construct the path, And if visited and minus 1 not is equals to 0, then just print out impossible, impossible. Else we have to construct a path, right? With the int path and int cur equals to n minus 1. We followed the zero-based indexing. That's why n minus 1. So while cur not equals to 0, path dot pushback cur and cur equals to parent of cur. Right? Perfect. Now at the end we have to insert path dot pushback 0 and we have to reverse it. Reverse path dot begin comma path dot end and we just have to print it for int I less than path dot size I plus plus cout path I plus 1 for one with indexing. Perfect. Next, we also have to print the size. Print path dot size. Perfect. Now let's try to run it. There's a mistake, but it is path dot size. Yes. I less than path dot size. Perfect. Yes, it gives us the right answer. That is 145, and the number of computers on this route are 3. Correct. So this is how you can print your path. The time complexity could be n plus n, and the space we are using also n plus n. Right. Thank you.